Okay, welcome Guadalupe and Terrence and Aria and Mark and Eileen and Warren and Tina and Kaylin. Thanks for coming. Today is all about chapter 6. Chapter 6 is not one of the harder chapters. We're only doing one chapter, but it is really important. We're going to be talking about the normal distribution. We have briefly discussed it already before when we talked about the empirical rule, and also just looking at histograms to see if it looks like it's a normal distribution. And we're going to get into more detail today. It turns out, and you would never guess why, but the normal distribution is the most important distribution of all statistics. It's one of those things, it's a big mystery until you understand the mathematics, and we're going to do that next week. So this week, you just got to trust me that the normal distribution is like that important. So again, we're going to be talking about the normal distribution. The other thing is, I want to remind you, there's something really big coming up that is due on Sunday. And let's see if I can, there we go. Okay, so there's one more thing that's coming up that is due on Sunday. And what is that? What's the big thing that's due on Sunday? And I don't mean the chapter 6 assignment. That's
Project 1.
Yeah, Project 1. So pay very strict attention to Project 1. So in particular, it's due on Sunday. And what the kind of my timeline is that by Thursday morning at 8 in the morning, okay, and before is fine too, if you send me your rough draft of Project 1, I'll read through it, and then I'll give you comments on how to improve it so you can better your grade. Those who don't send me the rough draft, I don't dock them or anything, but you're not going to see right away where you need improvement. And what I have found in the past is that those who don't send me the rough draft almost never get an A. Okay, and again, I read it fairly, so if you don't send it and you have an A paper, you still get an A, but it's pretty hard to do that because you're going to have things that you think are right that aren't quite right, or things that you missed that you were supposed to put in. Terrence asked how we send it, and the answer is, yeah, email. This is one of those you email to me because it's, the draft is not something everyone else in the class needs to see. That's just for me to look at and then give you a list of thoughts about it. About the draft is, if you can finish all of it, it may not be perfect, but if you finish all of it, that's best if you can send it to me. If not, send me what you got. I also will read them first come, first serve. So I'll probably start reading them Thursday morning, and what I do is the ones that come in get emailed to me first, get read first, and that means you'll have more time to be able to apply my feedback and make changes. Whereas if you are like at 7:59 a.m. on Thursday morning, sending it to me, because that's like your last chance, then you may have to wait until Thursday night before you hear back from me, because it takes me a long time to read these. These are many pages long, and I may have 20 of them for all I know. If you ever tried to read 20 drafts and each one is 8 pages long, it's a lot of reading. And I'm trying to write comments and the whole bit. So again, you got to pay attention. If you can do it a little bit earlier, then you'll be first in line. Look at it that way. And I'll definitely get it back to you earlier. So Thursday, most of the day Thursday, I have planned to just read the rough drafts. I am teaching a class on Thursday for a couple hours, but other than those couple hours, from 1 to 3 on Thursday, I'll be focusing on reading your rough drafts and giving you as much feedback as I can. Okay, and what I do is I tend to try and do somewhat like the top 10. So again, just because I gave you 10 things doesn't mean you have a terrible paper. It just means there's always things that you can improve on. So just to let you know that. So don't feel bad because I had a lot of things to say. Okay, if you send me a half-page paper, that's not going to be so good. Then number 1 will be you left everything out except this one item. So just note, it's really important. I will be checking the discussion forum, the Project One discussion forum and Q&A, but for the project questions, post in the Project One discussion forum. And I'll be checking it pretty often tomorrow. Wednesday, I'm not going to be in my office hours on Wednesday. As I mentioned last week, it's not the Jewish holiday, it's the last one. There's only 2 in the whole year. And the next one happens to be Wednesday. So I'm not going to be around Wednesday. Tuesday night, Wednesday, I'm going to be observing. So hopefully you understand that. But Thursday I'll be working on your projects, giving you feedback. Tomorrow I'll be answering any questions you might have. I'll be in my office. If you want to Zoom with me, or if you happen to live in Tahoe and you want to come by, whatever, you don't have to be in Tahoe to communicate with me. So that's really important. Make sure you're communicating with your partners. Don't assume they're doing their work. The number one complaint I hear, kind of stressful complaint, is my partner didn't do the work that my partner was supposed to do. So make sure you're communicating often so you keep touching base on where you are on the project. Okay? Or you might end up getting angry, and anger is never a good thing. It's much better to communicate than to just be angry. Are there any questions at all about the project or anything else, but the project should be the big thing right now? Any questions at all? This is a great time. I know I muted you, but you're welcome to unmute yourself and start talking if you have questions. Or you can, I'm also looking at the chat box, and you can do it that way too. Whatever you would like, but this is a really good time to ask questions. Questions? Getting silence. Okay, well, if there aren't any questions, I want to remind you, you can always post on the Project One discussion forum. The only thing you really need to email me is your draft. Okay, otherwise everything should be posted on the Project One discussion forum. Everything except the draft. Draft is just too long to have all the drafts posted. It's just kind of messy, so it's better to just be here. And then I can send you feedback a lot better, and not everyone's seeing the feedback, but that's a little more private, so that's why I feel that that's more appropriate for me. And there aren't that many things that are email-ish, but that's why. All right, if there aren't any questions, we're going to get into chapter 6, and I want to let you know, I talked in the announcement, I don't expect it for today to take as long as regular webinars. Chapter 6 isn't that hard. There's a few little concepts, and then we'll be done. So let me share. We'll do a Zoom, and we'll do a paint. Need water. So first thing, and let's see if you can remember, maybe you can pop in the chat box or say it, is what is the shape of a normal distribution? Yeah. So as Tina said, the shape looks like a bell curve, they call it, bell-shaped. So the first thing I want to do is I want to just draw it. So this is where I use my brush because I'm drawing. And by the way, you will find out really fast that I was not an art major, but I'm going to do my best. Not too bad. Okay. Still a lot of noise feedback. Let's some people. Okay, that might do it. Okay, so there's a bell curve, and that's the shape of the normal distribution. So in particular, to have a normal distribution, you need 2 important numbers. And see if you can remember, because they are the 2 most important numbers, or statistics or parameters, whatever you want to call them, depending on its sample or population, that we've had in this class. And what numbers are they? Yeah, the mean and the standard deviation. So the mean and the standard deviation. So let me write down how you write it. So let's suppose we had a normal curve, and I want to state the mean and standard deviation. The way you do that is you say x, X is your typical variable. Then I put a tilde, and then I put an N for, and you guess what N stands for? Hopefully you can maybe guess. What's N stand for? Mean? We wouldn't use N for mean. We'd probably use mu for that. Not sample. Here's a hint. What's this whole chapter about? Normal. So N stands for normal. That wasn't supposed to be a trick question, by the way. Okay, and let's suppose, I don't know, let's say we're looking at IQs. IQs are normally distributed, and the mean IQ is 100, and the standard deviation is 10. Okay, so that's an example of a normal curve. Any questions about that? And that's the notation we use. So if I say, write down the distribution of IQ scores, you write down exactly what I just wrote down. And that is X tilde N parenthesis 100 comma 10 and the parenthesis. And just let you know, on the midterm, I will ask you the question, what is the distribution? And it won't be about IQ scores, but you should know this notation. The way you read this, a tilde means has the distribution. The N is normal. The 100 is a mean, and the 10 is the standard deviation. Are there any questions about reading that? All right. When you have a normal distribution, the mean and the median are the same. So do you remember what the median is in terms of a picture? Because the median is easier to think about in a picture. In one word, what is the median? Yeah, it's a center. So the median is the mean, so that's also the center. And if you look at the distribution, it's also in the mode. So the mean, the median, and the mode are all the same. So normal distributions are very important because of that. Whereas like a uniform distribution, the mean and the median are the same, but there is no mode. For normal, you do have that mode. You have that tallest point. Okay, so in our case, the mean is 100. Just like so. Okay, so now if I asked you, for example, if we went, instead of just 100, let's say we went from 90 to 110. So now let's get some text in there. So 90 to 110. And I said, what is the probability that 90 is less than X is less than 110? And you might know this from memory. Anyone know? Especially if you've been working on your project, because this kind of stuff you might be doing. Any thoughts? Give it a minute. What is that probability? All right, let me state a couple words that might help. Empirical rule, does that help? It's not 50%. What's the empirical rule say? Because we move one standard deviation away on both sides. And what does the empirical rule say about that? Not 80, it's a good try. 68%. Not sure if you remember that, but that was important. So that was equal to 0.68. Okay, to 2 decimal places of accuracy. Do you remember that at all? Yeah, 68% is between -1 and 1 standard deviation away. So 90 is 1 standard deviation less, and 100 is 110 is 1 standard deviation more. How did we get that number? That was the empirical rule, Arya. That came from the empirical rule. How does that happen? To learn, you need to take my class this winter quarter called calculus. And that is not a requirement. But what you should know is that about 68% of the data is within one standard deviation of the mean. 95% is within 2. Do you remember that? And 99.7% is within 3. That was the empirical rule. Any questions on this picture? Okay, so now let's get into some more examples. So I'm going to get some more wordy example. So let me drop this. There we go. And let me pop another example in. Okay, so here's the question. And there's a bunch of parts. Suppose that X follows a normal distribution with mean 114 and standard deviation 23. So the first question is find the probability that X is between 100 and 120. So the first thing we do is we draw a picture. And hopefully you're going to get really used to these pictures because they come up in a big way. Okay, you don't have to be a perfect artist, but just kind of draw a bell curve looking thing. Not too bad that time. And then right in the middle, what number is that? What number goes in the middle? Yeah, 114 because that's the mean. Oops, let's try again. Any questions about that? Okay, now we want the probability that we're between 100 and 120. So what I'm going to do is I'm going to draw a line at 100. Notice 100 is to the left of 114, and 120 is to the right of 114. And I want this area. And now let's draw the numbers. I got it there. So that's 100. To 120. Any questions on the picture? Okay, now this is very different. This is not one standard deviation away, right? If you subtract 23 from 114, you don't get 100. And if you add 23, you don't get 120. So we're somewhere there. So this is where we have the calculator to the rescue. So I'm going to show you how to do this. Let me write it down because I'm about to lose it. Actually, I won't lose it. I'm good. So what we're going to do is we're going to go to our calculator. So I got to do a new share. And again, as always, when we do our calculator, I recommend you get your calculators out also. So you can follow along. Your calculator might look a little different. Let me clear what we had last time. Okay, so get your calculator out. And what we're going to do here is we're going to go second distribution. Okay, unlike the binomial distribution, this one's like right near the top, except one thing I don't like about Texas Instruments is here's normal PDF. If you ever use that in this class, it means you blew it. Well, we will never use normal PDF in this entire course. So for some reason, they put that as number 1. Number 2 is much more important. That's normal CDF, because that's going to be a full area. So I'm going to hit enter on normal CDF. Now this is the newer type of calculator. If you have the older type or the 83, then you're going to type these, what I'm about to type in, with commas in between and hit enter. and end parentheses and then hit enter. Okay, my lower bound is 100 because I want to go from 100 to 120. So my upper bound is 120. My mean was 114, and my standard deviation was 23. Any questions about entering in what we need? So you need your lower, your upper, your mean, and your standard deviation. Then I hit enter on paste. So if you have the older kind of calculator, you're just going to go directly, it'll go directly to this. You're going to type in 100, 120, 114, 23, and then end the parentheses. Then I hit enter, and I get about a 33% chance. Let me ask, are there any questions about using the calculator to find this probability? Looks like an IP address. Yeah, I guess so. Okay, but it isn't. Okay, so this is just some big number or little number, probability number. All right, let me unshare my desktop. Or not unshare, but go to Paint, go back to the question. Okay, and by the way, that looks about right. It's about a third I've shaded in. Okay, so now let's do the next one. Let's find the probability that x is greater than 200. So I need to redraw. Oops, let's try again. So there's my graph. Let's do this right here. There's the 114, and 200 is way over here. So let's type in those numbers. And then let's do some more shading. So greater than 200, so we go to 200. I'm going to shade this area. Any questions on the picture? Okay, so now we go back to our calculator. Again, you have no chance of doing any of these without a calculator. Okay, and not just any calculator. This needs to be a fancy calculator. So let's go to the calculator. I noticed there are a few of you on the expected value and standard deviation problems. You try to do it by hand. Boy, is it messy and horrible. And as bad as that is by hand, this by hand is really horrible. So good luck. You'll never get this by hand. Okay. All right. So what I'm going to do now is I'm going to go back to distribution. And now I'm going to go to normal CDF again. Our lower bound, if you remember, we wanted to be greater than 200, so it was 200. Now comes the interesting part. What is the upper bound if we want to look at all numbers greater than 200? Any thoughts? Yeah, it's infinity. But you can't really do infinity on the calculator, so you just do a really big number. You just throw a bunch of nines in. I recommend 2 more nines at least than the number of digits we've got. So I've got 3-digit numbers in this problem, so I'm going to go 5 nines, and that will always work. Okay, the mean and standard deviation are the same. I don't have to do anything. And I hit paste, and then I hit enter. All right, so is the probability 9.2 or so? What do you think? I see on my calculator 9.2. Is that the probability? Okay, Mark says no. How come? What is this probability? Yeah, we got to look at that E-5. That E-5 means the decimal needs to be moved 5 places to the left. The first place just moves it to the other side of the 9, and all the rest give you a 0. So one of them gives you just a move to the other side, and then 4 zeros. So the answer is going to be 0.00009. So let me just type that in. 0.00009, maybe 236. And that is actually the answer to this probability question. Any questions at all so far on finding those probabilities? Any questions? Okay, so now let's do the next one. There's a lot of these. Okay, so the third one. Let's find the probability that we're less than 90. So again, we draw our picture. You're going to get used to this picture, hopefully. Oh, don't want it red, don't want it black. And let's do this. And then this. That. And then I'm going to put in some text. There's 90 there. It's not ready yet. So 90. And our mean was still 114. That's not changing in this particular problem. And we want to find the area. So we do something similar. We go to our calculator. So let me go to our calculator. And we want to find a probability. We're going to go to, again, second distribution, normal CDF. What's the low this time? Not 0. You could actually go to the left of 0. -1 is less than 0. Yeah, we need -99999. Okay, so just a note, you need to use this negative sign that's below the 3. Don't use the minus sign to the right of the 6. You'll get an error if you do the subtraction sign instead of the negative sign. So negative, and then a bunch of 9s. And then the high number is going to be 90. And then the mean and standard deviation are the same. Any questions so far? And I hit paste, hit enter, and I get about 15%. Any questions at all on this one? Question? Your answer was the same with 0. So it says 0.14836? Is that what you're saying? Is that what you mean by answer the same with 0? I'm not sure where the 0 was. Oh, it was the same whether you had a 0 or a -99999. Yeah, now see, you got to be careful because sometimes you'll get lucky and it'll work, and sometimes you won't. So my recommendation is put a bunch of 9s in. Because especially in a test, do you really want to hope you get lucky? It's much better to just stick the 9s in and then you know it's always going to work. And if you use 2 more 9s in the number of digits, guaranteed it will work. If you use a 0, sometimes it works, sometimes it doesn't work. So that's my suggestion. Okay, and it has to do with how many standard deviations away from the mean it is. You don't have to do all that work. Just throw a bunch of 9s in and you're good. All right, so now let's do, I'm going to skip D because we don't really need to do that, but I want to get to E. So I want to get to find the IQR. Now, who remembers what the IQR is? Who remembers what that means? By the way, as part of your project, you better have an IQR and do a full explanation of it. So that's why I put that in, because it's on your project. Yeah, IQR is the interquartile range, and that means the 25th percentile to the 75th percentile. So I'm going to draw a picture. Okay, and we're gonna do a lot of, that's what this is all about, is pictures. So I'm gonna draw a picture. And as you get used to, they're all the same. They're normal distributions. Just which numbers you've got and stuff are important. And we know that the mean is still going to be 114. Okay, we don't know what the IQR is. We don't know the values of X for the first and third quartile. If we don't know them, let's just pop something in. We can kind of eyeball it, and that's going to be good enough. So you figure about there or so to about there. Something like that. And we don't know these numbers. We give them letters, and let me use the symbols that you're used to using, or at least we've seen before. So this one is Q1. And the next one is Q3. Okay, what we do know is that if I look at the area to the left of Q1, what is that area? Yeah, 25%. It's better to write as a decimal, though, which is 0.25. Because we're using a calculator, and calculators need decimals, not percents. Okay, because that's what the first quartile was. Any questions on that? Similarly, if we want to find out the area to the left of the third quartile, I'll do that one in green. Fresh. So this green area is how much? Yeah, that's 0.75. Good. All right. Well, this is a little weird because what we've been doing for all the other examples is we had an X and we want to find an area, right? Now what we want to do is we have an area and we want to find the X. So now let's see if anyone remembers their math. What do you call it when you have a function and then you decide to go backwards instead? What do you call that function if you're going backwards? You're doing everything in reverse. Who remembers the name for that? The math word. Regression, good try. We're going to do that in a bunch of weeks, but that's a different thing. Regression's important, but it's not what I was just talking about. So what do you call if you have a function and you want to go in the other direction? Instead of going from x to y, you want to go y to x. What do you call the new function? You remember? Probably happened way back enough. Yeah, Alex remembers. Inverse. So what we're going to do is going to use what's called the inverse normal function, because we want to do the inverse of being normal, going backwards. So now what I do is I'm going to go to my calculator, now that I have that idea. And I'm going to go to distribution. And you'll see, which number do you think I'm going to use to find the inverse of the normal distribution? Okay, number 3. Number 4 is the inverse of the t distribution. The t distribution will happen in a couple weeks, but we're not there yet. Number 3 is the inverse of the normal distribution. There's lots of distributions, by the way, but the normal is the biggie. That's why it's at the top. So we can go number 3, which is inv norm. And I hit enter. So the area, let's do the first quartile first, is 0.25. Our mean, if you remember, was 114. Our standard deviation was 23. And I go ahead, hit enter and paste. And that gives it, the old calculators is just going to say in norm of the parenthesis, you put 0.25, comma 114, comma 23, and you end the parenthesis. Then I hit enter, and I get about 98.5. Any questions on that? Okay, for the third quartile, I have two choices. One is to go back and do exactly what I did, but make it a 70.75 instead of 0.25. But I want to show you a little trick on this calculator. If I go second, enter, it gives me back what I had, and I can go over. All I want is that 2 to become a 7. So I just move it over, type in a 7, and hit enter. Any questions on finding these numbers, 129.5 now? Okay, so now what I can do is find the IQR, which is subtracting the two numbers. So 129.5, and then minus. And then we had 98.5. I hit enter, and there's my IQR. So the interquartile range is 31. Any questions at all on going backwards? Any questions? Okay, so now let me try another one. I'm going to erase this, but let me know if you don't want it. You better hurry though, because it's going to be erased very soon. For an exam, is drawing the distribution showing the shading and numbers we enter into the calculator sufficient for showing your work? Yeah, that's the whole thing. What else? What other work is there? Yeah, so that's pretty much what you can do with, like I said, I would type in normal CDF, you know, and then like on part C was -999, comma 90, and the comma 114, comma 23. Okay, so that's what you do. It only takes a couple seconds to do it. It's worth doing it. Because that way, if you make a mistake, I can fix it. Oh, Q2. Okay, so Alex has a good question. See if someone can tell me. You don't need a calculator for this. What's Q2? See if anyone can tell me what Q2 is. Yeah, 114. In fact, we don't even use the letters Q2 because we have a word for it. It's called the median. And the median and the mean are the same for normal distribution. It's just 114. So there's no reason to even ask that question. That'd be kind of a trick question because it's too easy. Do you agree? If I said what is Q2, because you don't go to your calculator on that one. That's why you've probably never seen Q2 written down because you just call it the median. Okay, so I'm going to erase, and I'm going to pop in another question. It's a fun little question. All right, so here's the question. It says, suppose that the time until you, or your wife if you're male, will give birth is normally distributed with a mean 140 days and a standard deviation of 7 days. Okay. By the way, I don't know if I don't know about the ones that are happen to be present, but it used to be normally distributed and it's not anymore. Okay, this is not a math question, but anyone know, especially those in the medical field? I know some of you want to be nurses and other medical type things. Anyone know why it used to be normal, but it's not anymore? Kind of one main letter, actually. Preemies, I've always had preemies. Nope. Any other ideas? Got obstetrician nurse, yeah. C-sections, you heard of them? So it turns out humans naturally have a normally distributed birth timeline. But with C-sections, we've just like destroyed it. So we're gonna pretend that we're not gonna do C-sections. Sound good? Because nobody's that late anymore because then they just pull it out if you're really late. Okay, so everything changed with C-sections, but we're gonna pretend that there's no C-sections. Okay, so now the boss has just scheduled you or your wife, okay, if you happen to be male, for a business trip to China. Okay, okay, may not be a really good idea if you're pregnant, but you know, you have a job and you don't want to like lose your job either. So you or your wife will leave today. Okay, and you're going to return in 135 days from today. So let's find the probability that your baby will be born in China. Any questions so far? Any questions? All right, so the first thing is we need to draw a picture. So let's draw a picture. First thing, there's a keyword here, and that's it's normally distributed. That means we know what our picture looks like. I hope you all know. That means we get to draw a normal curve. Yeah, and 140 is the center of the bell curve because that's what it means for you to be normally distributed with mean 140. By the way, what's the medical, it's not a fancy medical word at all. What's the medical word for 140 days in this case? This is a word you all know. You don't need to be a doctor or anything. You've all heard people say this. Any thoughts? As soon as I say it, you'll say, of course, but maybe someone will get it. Okay, a couple words people use. Gestation, that's kind of fancy. Due date, when are you expecting? Right, that's the word, right? When say, hey, when are you expecting? I'm expecting in 140 days. That's what that means. That means that is the mean of the normal distribution. Okay, your due date or your date of it that you're expecting. Okay, so I'm going to draw that due date, which is 140. So let's do that. There it is. Okay, now we want to find the probability that the baby is born in China. Okay, if it's born in China, what does that mean? When did it happen? Yeah, that's less than 135 days because that's when you're returning. So I'm going to sketch right about there. Okay, this is one where we can actually go to 0 if you want, and that's pretty safe because the baby didn't happen yesterday. So 0 is pretty safe there. So now I'm going to put in the numbers. Just like so. Any questions on that? Okay, so now the problem's looking pretty like the last one, isn't it? So we need our calculator. There's no way you can do this without your calculator. So let's go to our calculator. So now I'm just going to go to second distribution. Am I doing normal CDF or am I doing inverse norm? Okay, are we trying to find a probability? Are we trying to find the area or are we trying to find the value of X? Yeah, this is the normal CDF because we're trying to find the value, we're trying to find the area, we're trying to find the probability. So we're going to go, oops, normal CDF. And the lower, I'm just going to put 0. And then the upper in this case is going to be 135. The mean was 140. Okay, and it's kind of interesting. I don't know if it's a coincidence or what, but a week is actually the standard deviation, 7 days. Okay, I looked this up and that's what it said, so it's kind of cool. So I'm going to hit paste and then hit enter. All right, so we got about a 24% chance. What do you think? Are you good with that? If you're pregnant and there were a 24% chance you're going to have your baby in China, would you be happy with that? Okay. Okay, or are you going to miss the baby because you're in China and your wife is in America and you like missed the birth? Okay. I hope that any of you would say, forget it. Okay. Okay, that would be really a bad idea. Okay, so here's part B. Okay, so you decide that this is too risky and want to negotiate with the boss. Okay, so it doesn't mean you shouldn't go to China, but you want to make sure that you're going to come back to America in time so you're pretty sure you're going to have the baby in America. Let's suppose for negotiating power, you're going to say, well, we're going to be okay if there's just a 1% chance because that's a small enough percent chance. So we're going to be okay with no more than a 1% chance the baby's going to be born in China. When should you return? Any questions on the question? All right, so now let's go and do it. I always do that. Let's make it black. Let's draw a picture. We're in the same scenario, so the mean is still going to be 140. But now what we're going to do is we're going to say, hey, we do not want it very likely at all for the baby born in China. We're going to put it way over here. We don't know exactly that number, but we're going to put it way over here. Any questions so far? All right, now we want a 1% chance the baby's going to be born in China. So that is that area right there. So that area will be 0.01. So now we're going to go ahead and let's do one more text. We don't know this number, and if you don't know it, you call it X. Okay, before we had like a Q1 and a Q3, but here we really don't know. All right, how does this differ from part A? What's the difference in this one that we're doing now, part B and part A? Yeah, this is going to be inverse norm because now we're given the probability we want to find the value of X. And you see how the picture shows you that? So I do want you to get good at drawing these pictures. So we're going to have an inverse norm. So let's go and let's do a calculator share. So now I'm going to go back to my distribution function and go my inverse norm. And my area is 0.01. My mean, that hasn't changed, it's still 140. And my standard deviation was 7. And there it is. I hit paste. And this says I need to return in, I would say, I would round down, you're negotiating here. So negotiating always go a little low. I would return in 123 days. And then you're pretty darn safe the baby be born in the United States. Okay, and by the way, if you want your baby to be president of the United States, then it better be born in the US. That's in our Constitution. Okay, so can you reverse it, check your answer? You can if you want. I usually check it by just looking at it, saying 123.7. So now I'm about 123. So now let's go, I'll show you how I look at it. Does that look like it could be 123? Standard deviation is 7 days. One standard deviation down would be 133. 2 would be 126. So it's a little less than that, and that's about right. That's kind of how I check it, is I check it with a picture. Okay, any questions on this? All right, next question. Okay, the next question is, it's now 138 days, 38 days later, and it's still not been born. Find the probability of the baby will be born within the next 24 hours. Okay, this is a different kind of problem. Any ideas on how we're going to approach this? Because we know it wasn't born in the first 138 days since today. Any thoughts? That's a tough one. Any thoughts on this? All right, here's a okay, then find the area. Can you reverse it? Check your answer, find the 138 value first, then find the area of 24 hours. Kind of, but not quite. So the hint is chapter 3. I know you were all thinking about that, but didn't want to type it in. This is a given problem, right? This is, we know some information, we want to find a new probability, and that's an A given B problem. So what we want, let's put this in symbols. So we want the probability that, well, we want the probability that X is going to be between 138 and 139. And we're given the fact that X is greater than 138. Any questions on that? That this is what this question is asking? What is the probability that it's going to be born between day 138 and 139 if you already know it's after 138? Okay. Yeah, so now you got to remember the formula. Okay, by the way, for the midterm, if you don't want to have to memorize, stick it on your note card. So remember, probability of A given B is the probability of A and B okay, well, if it's between 138 and 139 and it's greater than 138, that's the same thing as it's just between 138 and 139. 138 less than X less than 139. And then we're supposed to divide by the probability of B. So divide by the probability that X is greater than 138. Any questions on that? Okay, so to do that, I'm going to go ahead. What do you know? I'm going to draw a normal distribution curve. In fact, I'm going to draw 2 of them, one at a time. Always have 140 as your mean. Actually, I think I'll make it a little smaller. So there's our mean of 140. Let's find 138 to 139 first. So that's somewhere between here and here. So we have 138. There's not a lot of space here. So I want to go. Oh, what just happened? Oh, I know what happened. This happened. There we go. And then 139. And we want to find that area. And then we're going to divide by something very similar. Probability that x is greater than 138. So again, normal curve. 140 is the center or the mean. And we want to look at greater than 138. And that's all this stuff. Better. And then 138. Any questions about the two pictures? So we can see we're going to divide the small area by the bigger area and see what we get. And let's go to the calculator now. So I'm going to go to second distribution. And this is finding an area or finding a probability, so it's normal CDF. And let's go 138 to 139. Our mean, again, was 140. Our standard deviation was 7. And there's that area, about 0.05565. Then I could do the same thing, same mean standard deviation, but now we're not going from 138 to 149 anymore. Now we're going to go from 138 to how far? Yeah, a bunch of 9s. And everything else is the same. Pop that in. So then our final answer is we're going to divide the two. So 0.05565 divided by, and then 0.61245. And we get about a 9% chance. Any questions on this idea? Any questions? Okay, as I mentioned, today is a little shorter. Let me give you a secret word. Let's reshare. And I can pop it here. How about haven't used orange yet. Make it big because it's a secret word. And the secret word is unimodal. Do you remember what unimodal means? Yeah, one mode, and notice the normal distribution is a unimodal distribution. So that's why this is a secret word for this week, is this is one of the descriptors of a normal distribution, is you have it's unimodal, it's symmetric. Those are two of the biggies. Okay, so that's all I have to say. We've made it before 7. Okay, usually I've been going like to 7:25 or so. But again, today's a little shorter. We have less to talk about because you got your big project due. So I'm going to stop the share. And if you have any questions, this is a great time. Could be about anything, could be our project, if you came up with some new questions about your project. But I'll be happy to answer any questions you might have. And I want to remind you, I won't be in my office on Wednesday. I'm missing Wednesday. But I am in my office tomorrow. I'm happy to talk to you online, whatever you need to help you out, especially about the project. Because that's what most people right now should be really focused on. Okay, Terrence, you have a good evening too? Yeah, Mark, you have a much newer TI-84. That's what that means. So we're doing left tail. All the examples I did were left tail. Okay, any other questions? Have a good night, Tina. When is the Math 201 exam due? Okay, so first thing, there's 2 written exam and 1 online exam. So Guadalupe, if you're talking about the online exam, that is due on the 20 something. Just a minute, let me double check. I checked pretty recently. So let me go ahead and find it. I think the syllabus might be the easiest way. Just 1 second. That's due on the 20th at 11:59 p.m. Don't wait till the last minute. Next week I'll talk about that. It's a little early still for that one. Do we have to submit the attached exam form? No. The online exam is just truly pure online, no proctor necessary. You have as much time as you want. It looks like the homework, except that you don't get to repeat problems, and it's much longer. But next week is the time to talk about that. Right now, project is what you want to focus on. You shouldn't start that now because the online exam has chapter 6 in it, and you haven't had enough chance to practice chapter 6 yet. So it's a little bit early still. So right now, the project should be your main focus, and maybe the assignments from chapter 6. There's a discussion post due. It's one of the easier discussion posts. Hopefully you'll all do fine on that one. So what's hard is the project, that's for sure. Okay, any other questions? Guadalupe, Mark, and Warren, and Constance, Alex, Brittany? Any questions at all? If you don't have questions, you can always say goodnight, but I'll be happy to answer questions. Okay, have a good night, Mark. Okay, thank you. And don't forget, Thursday, you got to have the initial post due, always on Thursday. So don't forget about that. Have a good night. Can you do an example on finding the standard deviation on the calculator real quick? Okay, I can do that real quick. You mean when you have data? Mark, Alex? Yeah, so that's a quickie. Okay, so you just go to stat, you go to edit, you clear out L1, hit enter, you put in your data. So I'll just throw in some numbers. Let's say you have 6, enter 9, enter 2, enter 4, enter 3, enter 4, enter 5, enter 4, enter 6. Sound good? Okay, again, if you want, oh, sorry, you can't see that yet. Sorry, let me share. Just realized that. Let me start over. Let's go to quit. Okay, so what you do is you go to stat, you go to edit, and then what you do is you go to clear your L1, and then we enter our numbers. So let's say you had 8, enter 2, enter 4, enter 4, enter 3, enter 7, enter 5, enter 8. Just a bunch of numbers you want to put in the calculator. Remember, you're not allowed to use your calculator for the project. You have to use a spreadsheet. So if you think you're using your calculator for your project, that's not right. Okay. So then what we do, it's not showing chat. I guess it's fine. We go to stat. We go to calc. We go to one var stats. Okay, now, depending on the kind of calculator you have, this version of the 84 looks like this. Our list is L1, so that's good. If it doesn't say L1, you type second one. Freq list, we don't have a freq list, so let's hit clear. And then hit calculate. And if it's a sample standard deviation, it's this SX 2.295. If it's a population standard deviation, it's sigma X 2.21469. And that's all there is to it. Okay, let me unshare. Okay, any questions on that? Yeah, it's real important to know how to use a calculator, but not for the project. For the project, it has to be a spreadsheet. Don't touch your calculator. Because you can do everything with your spreadsheet and you have to. Okay, any other questions? Alex or Warren or
Larry,
Brittany or Guadalupe?
Larry?
Yeah.
Just one more question for you, man.
Sure.
You know, like the B minus A square root over 12.
Yeah.
I'm having a hard time finding that out on like my calculator.
Ah, so not standard deviation with data. Now you're talking about standard.
That's the one I was asking about. I'm sorry.
Oh, okay. Yeah, so I asked with data. So that's not with data. That's with a uniform distribution. Okay,
Yeah,
so let's suppose we had said, let's say something was uniform between 5 and 20. Sound good?
Yep.
And let's find the standard deviation. So the first thing is, let me do some sharing. Let's select, gotta get rid of everything else because I have no more space. Okay, the first thing is we need the formula. Let me just do it with a brush. So that is standard deviation is equal to the square root of B minus A squared over 12. Is that clear so far?
Oh, I think it's still on your screen.
Oh, sorry about that.
Oh, that's all right.
Yeah, I always forget to share. Sorry about that. If I don't hit share, then you can't see it. There we go. Now you can see it.
Yeah, that's the one I've been trying to figure out on the calculator, but it's
so let's suppose we were between 5 and 20 for uniform distribution.
Okay.
So that case would be equal to the square root of 20 minus 5 squared divided by 12.
Mm-hmm.
Okay, now I'm going to pretend that you don't even know how to do arithmetic. Sound good?
Yeah.
So we'll put it all in the calculator. So now I'm going to share my calculator. And the key is parentheses. In fact, maybe I'll do it first outside the calculator and then I'll like what you would put in. Square root is SQRT. I'm just going to write it that way. Not in the calculator, but just so you can see.
Mm-hmm.
Of parentheses, and then parentheses, 20 minus 5. And then square, often you do caret 2, and then divided by, oops, missed, there we go, 12. And then close the parentheses. Okay, so that's kind of what it's going to look somewhat like on your calculator. Is that clear so far?
Yeah.
All right, now we'll go to the calculator. So let's do a new share. Let's just clear what we have. Okay, so now what I'm going to do is I'm going to do square root. Square root is the second x squared key. Any questions so far?
So far, so good.
Now parenthesis, remember the parenthesis?
Yeah.
And then parenthesis again.
Oh, okay.
And then 20. Remember there were two parentheses that I had on the whiteboard, right?
Yeah.
Minus 5. And then n parenthesis. Now you could hit x squared, and that'll square it.
Mm-hmm.
And then divided by 12. And then n the square root parenthesis.
Okay.
Got it?
Got it.
And then I hit enter. And you get about 4.33.
Oh, okay. Yeah, I think I was missing that second parentheses.
Yeah, parentheses will get you on a calculator. They're really
Okay.
important.
Perfect. Cool. Thank you, Larry.
Okay, great. Okay, any other questions? Brittany or Warren or Guadalupe? Or Alex? Any questions at all? Give you a moment or two. Okay, thanks, Alex. Good night. Brittany, Warren, Guadalupe? If you're quiet, that's fine. We'll say good night. Give you a few seconds. All right, have a good night, Guadalupe. Warren and Brittany, any questions? Okay, I think I'll say good night since you're being quiet. For all of you who are watching this as an archive webinar, don't forget the project is due on Sunday. Don't wait till the last minute. Strongly recommend by Wednesday night, and maybe even Wednesday day, you email me your draft so that I can give you feedback. After 8 a.m. on Thursday, I won't look at it. That's just a note. Don't say, I'm sorry it's late. I'll say, I'm sorry, but you can post questions on the Project One discussion forum. So send me what you've got, and then I'll look at it by 8 a.m. on Thursday, but the earlier the better, so you can be first come, first serve. And I will see you next week. There's a good chance we'll do Tuesday just because we did Monday this week. I tend to do every other unless I have something going on that I can't get out of, but usually, or if there's a holiday. So there's a good chance it's Tuesday unless I hear a lot of requests. If 6 people want it on a certain time that I can make it, then we can do that too. But have a great night. Goodbye, everyone.